In lesson 3.1, we're going to work on getting things done, just starting off a little bit different here, and our little learning progressions that we're going to go through. So the objectives here are to build on our current positive and negative rational number understanding, which you've already learned in modules 1 and modules 2. The key understandings for you to remember, this is new. Rational numbers can be written as a divided by b when a and b are integers and b does not equal 0. So kind of introducing some algebra here for you guys. A represents a number and b represents a different number. But remember, when you're creating a fraction, b cannot be 0 because that is considered undefined. And then every rational number can be written as a terminating or repeating decimal, and we'll go into that in the lesson. And then converting a fraction to a decimal. You take the numerator, which is called the dividend, and that is divided by the denominator, which is called the divisor. So I have a little trick I'll show you there later on in the video and how you can help set that up and what you're going to have to do. So here we are in the lesson. 3.1 rational numbers and decimals, and if you look over here, here's our standard that we have to satisfy. So converting a rational number to a decimal using long division, there's a great example on the next page that's going to show that. I'm going to work on how to help you set it up, and know that a decimal form of a rational number either terminates in 0 or eventually it repeats. Our essential question is how can you convert a rational number to a decimal? And pretty much your answer is going to be, we're going to use long division on how to do that. So the first thing is that we're going to talk about what a rational number is. It can be written as a ratio of two integers, a and b, where b is not 0. That's what I talked about at the introduction. So they take the example here of 4/7 as a rational, and that can be converted to 0.37 or 37 hundredths is the way it properly should be said. And this is what it would look like in fraction form, and we'll help you with a little trick on how to go ahead and set that up when you're going from decimal to fraction. So going here, they have a bar. It says use a calculator. I do not want you to use a calculator. I want you to do this by hand because it says in the standard using long division. It doesn't say using a calculator. It says using long division. So we have to set this up as in our long division on how to do that. And I want to go ahead and show you a little trick on how to do that. Okay, so our fraction that we had was 1/4. So if we recall, the numerator is on top and the denominator is on the bottom. So I want you to think alphabetically. So D comes before N. And when we write this and we set it up for long division, we take the D goes on the outside of our division sign, and then our numerator goes on the inside. So alphabetical, D is divided into N. When you guys normally write things, you would either see this, 1 divided by 4, and that would be correct. And what most students do is they go ahead and they take 1 divided by 4. That's how they think about this. This is wrong. This is the way that you have to do it here. So the 4's are denominator, so 4 goes on the outside and 1 goes in on the inside. Now this is a series of questions that you ask yourself, and you have to know your math facts. So you ask yourself, 4 goes into 1 how many times? Well, it's 0. So then we put our decimal in here, and we add a decimal. Have we changed this number by adding 0 to 1? Well, the answer is no, because it's still 1. We just say it's 1.0. Okay. Now we ask the question, how many times does 4 go into 10 without exceeding 10? The answer is going to be 2, so we need to know our math facts there, because 4 times 2 is 8, and then we subtract that. So then we have 2. We haven't found out yet if we're a repeating or a terminating number, so we're going to add another 0. Terminating decimal is looking for 0 at the end. Okay, so I have 20. How many times does 4 go into 20? Well, it's 5 times. 4 times 5 is 20, and I'm at 0. Has this terminated? Yes, it has. So my answer of 1/4 is equal to 0.25. So if you follow the steps that I showed you for 1/4 and do that for these three, then you'll be able to go ahead and figure out what the answer is. Let's go ahead and look at this improper fraction and see how that goes. So I believe it was 12/5. Again, this is the denominator, the numerator. So it's the denominator is divided into the numerator. So I'm going to set it up as 5 divided into 12. How many times does 5 go into 12? Well, it goes into it 2 times without exceeding it, and that is 10. So I'm left with 2. Haven't terminated it yet or found if it's repeating, so I add a 0. So 5 goes into 20 how many times? And that's 4. And I finish with 0, so I am done there. Okay, so 12/5 is equal to 2.4 in decimal form. Okay, and then for these two here, we're going to go from a decimal to a fraction. I want to show you the little trick on how you guys can do that. Okay, so we have 0.2 is our 1. So we go to fraction form in this way. Draw your fraction bar, write your number down in your numerator without the decimal, and then in the denominator, write however many digits that you have here, how many spaces. So we only have 1, so we put a 0 there, and then we write a 1 in front of it. So 0.2 or 2/10, okay, is the fraction form. The other one, 0.875. We do the same thing. We write our fraction bar. We bring down our 3 digits, so 8, 7, 5. And because we have 3 digits now, we're going to add 3 zeros to the denominator. And then we place a 1 in front of it. In both cases, you have to try to get this down to its simplest form. Okay, so you got to do that in both of them. When you cross a number that does come up and that's going to be repeating, you got to make sure that you go ahead and write this bar up on top. I'm also going to ask, instead of you writing the where it says 0.3, is go ahead and add a couple more digits. So 0.33, and then put that bar on there. Because what could happen is that if this bar is missed, then somebody's going to see that and it's going to look like 0.3, and that really means 3/10, not 1/3, which will be repeated. So you have your conjecture to do here. Conjecture is you're going to make a statement of your beliefs there. It's kind of like a hypothesis. You have a reflect question to go ahead and do. Integers that went ahead and showed you on the slides here, these have all been terminating, okay, because the decimal comes to an end. But the other ones that we have is called repeating because they repeat indefinitely. I'm going to go ahead and I'm going to take you and show you a real simple example on the next back here. So let's just go ahead and do 1/3. 3 goes on the outside, divides into 1. Series of questions. 3 goes into 1 0 times. So I'm going to bring my decimal, add a 0. 3 goes into 10 3 times because that would be 9. So I subtract. So I'm 1. I bring a 0. I haven't terminated in 0 here yet. I bring this down. 3 goes into 10. Oops, I didn't write my 3 up here. 3 goes into 10 3 times. So that's 9. I subtract. I do 1. And I do it one more time. I would like you to get into the habit to at least do this 3 decimals, because there's some patterns that won't repeat until you hit 4 or 5. Also, do not count on the calculator, because there's a couple of numbers out there that will repeat, but after the number of decimal places that is shown on the calculator. So as you can see here, we're constantly getting the 3, so then 1/3 is equal to 0.333, and that's repeating. So that's a repeating, and it will go on indefinitely. I love this example. Again, it shows you how to set things up. Okay, so we have our denominator over our numerator. So that's our denominator here. This is our numerator in there. Okay, just like I showed you before. And then you go through the series of questions. Okay, 16 does not go into 5. That's 0. Add a 0. 16 goes into 50 3 times. Again, knowing your math facts. Hey, you know, if you have to, come off over to the side. You know, 16 times 2, Okay, that's 2, carry 1, that's 12, 13. Oops, I can go probably one more time, so there's 16. So that would be 48, okay, so, but I don't exceed. So if you got to do this, go ahead and do it, all right? But look how they keep things organized. You don't have to use graph paper to figure this out, but notice how everything is organized in a line, okay? That's critical. It's one of the big mistakes I see students find. You have a couple different examples here, okay, that they show you. So go ahead and follow that. So you have your turn here. You got some examples. Notice here they throwing in the negative. You're still going to do the 4 divided by 7, and you're just going to use that negative. Okay. You have your 1/3, and here you have negative 9/20. Do not forget the sign. Remember the sign. You have to use that. And then here we have mixed numbers as decimal. Now, there's a real simple way, and I like what the book has done here for you. When you're dealing with just one number, okay, just separate the number out. So if we look at this, let me rewrite this here for you. Isn't 6 3/4 the same or equal to as saying 6 plus 3/4? Okay. So all you really have to do is just work with that right there and then bring it back in. So that's what they're showing you here. They're going through the same steps. 4 is the denominator, 3 is the numerator. 4 does not go into 3, 0 times. 4 goes into 30, 7 times, so that's 28. Go through the steps, and then you just recombine them, or you re-add them together. So 6 plus 0.75 is 6.75. So this is a great trick. You don't have to worry about taking the 6 3/4 and going from a mixed number to an improper and then going through the steps. So it's another way. As we keep going down, you have your turn here. So I hope that helps you out, and I hope you do well.